A block of mass 0.5 kg hanging from a vertical spring executes simple harmonic motion of amplitude 0.1 meter and time period 0.314 seconds. Find the maximum force exerted by the spring on the block. Alright, now let's say this is my spring. A block is hanging from it. Right, now what happens is that when a block is hanging from a spring or spring constant K, then first of all it will come to an equilibrium position. At that very instant the spring force upward will be equal to mg. Okay, and now if I further move it by a distance x downward or upward, then it will start executing simple harmonic motion. Okay, now this distance x by which I stretch the spring is my amplitude over here. Right, I had to calculate the maximum force exerted by the spring on the block. Fine, so first say at equilibrium condition, that is when the particle is at rest, at that very moment spring force will be equal to mg, because that is an equilibrium condition, nothing is happening, block is stationary. Fine, so the initial spring force will be mg. Now if I stretch the block further down by a distance of 0.1 meter so as to perform simple harmonic motion, then if I stretch the block again by a distance of 0.1 meter, an extra spring force will develop, and that spring force will be equal to kx, obviously from the mean position, with respect to mean position, definitely. Alright, this distance is x, then this is the extra spring force that is developed. Fine, so at that instant the total spring force or the total force that is acting on the block will be equal to mg plus kx, that is the earlier spring force plus the extra spring force, that will be my total spring force. Okay, now I have to calculate the value of k because I know the value of m, g is always known, and x, that is the amplitude, is also known. I have to calculate the value of k. So it can be calculated by the formula T is equals to 2 pi under root of m by k. This is the formula to calculate the time period of a spring execution. Fine, so time period is 0.314, that is pi by 10 into 2 into pi under root of 0.5 by k. So pi is cancelled, it comes out to 1 by 20 whole square is equals to 0.5 by k. So the value of k comes out to be 200 Newton per meter. Right, so I do have a value of k now, so just substitute this value in this equation. The total spring force comes out to be 0.5 into 10 plus 200 into 0.1. So this is 5, this is 20, so it comes out to be 25 Newton. That is the answer.